In this first lesson in our course, we're going to be looking at ratios. Ratios are an important everyday concept. We probably use it without even thinking about it. For instance, for mixing gas, we got to use 1 part oil to 12 parts gas. Or making cookies, we got to use 1 egg for every 3 cups of flour, for examples. The whole idea of a ratio is it's a way of comparing things that don't have the same types of units. Or they could have the same types of units, but usually not. Ratios can be written as fractions with words, or most commonly with a colon between them. That's what we're going to use most of the time, colon, so like the 2 dots. Okay. So for example, we had a group of 12 students and they're choosing lunch. 5 chose pizza, 7 chose hamburgers. The different ways you could write them are relating the 5 to the 7. Now, the question tells us what order to write these in. In ratios, it's really important which order you go in. So it says pizza, 2 hamburgers. So how many pizza people do we have? I think there were 5. So we could write 5 to 7. Or if we want to do it as a fraction, 5 over 7. This is my pizza, this is my hamburgers. And different ways of comparing 2 different units. In this case, they're both people, but they're choosing different things. Let's take a look at this next example here. We've got a whole bunch of shapes. Can we figure out some different ratios that compare these things? There's no one right answer. There's a whole bunch of answers. For instance, we could say we have 3 triangles to 3 circles. That would be a ratio. We could say we have 2 yellow shapes to 3 blue shapes. We could say we have 1 yellow circle to, what do we have? 2, 4, 6, 8, 10, 9 other shapes. Okay? Just different ways of comparing things and using different identifiers to come up with different ratios. Okay? It could be the shape, could be the color, it could be a combination of those things. Lots of different ways of comparing things. Remember, a ratio is just a comparison. Okay, what is the ratio of boys to girls in this class? Now, for this one, you actually have to be in the classroom. Turns out in our classroom this year, we have 7 boys to 6 girls. We can also compare students to teachers. From here, we have 13 students to 1 teacher. Now, if we count the other adults in the room, sometimes we have 13 students to 3 adults. And it's a pretty good ratio, right? You can get lots of help in this class because there's quite a few adults compared to how many students we have. Notice that word compare. A ratio is comparing things. All right, let's look at some more examples here. To adequately cover a stance, there needs to be 1 adult for every 20 students. What is the ratio of adults to students? Well, if I'm comparing my adults, there was 1 of them, to, that's my ratio, students, there's 20 of them. Or to be honest, a better version, which I'm going to use most of the time, will be the fraction version. 1 out of every 20 adults to students. Sometimes it helps to put the A and the S there to remind yourself of what's happening here. Part B of this question asks what happens if there's 2 adults. How many students could come to the dance? Well, if I have 1 for every 20, that really means I should have 2 for every 40. I should be able to just double this. Right? Times the first thing by 2, I can times the second thing by 2. In other words, 2 to 40. Or 2 to 40. How about if we had 5 adults? Well, it's kind of hard to convert a 2 into a 5. But if we go back to the beginning, how can I turn a 1 into a 5? Multiply by 5, right? So if I times a 1 by 5, I can also times the 20 by 5, and I'll get 5 over 100. Sometimes it's easy, oops, not 200, 100. Sometimes it's easier to see it in a fraction form. This is 1 out of 20 is what we started with. If we times it by 5, we get our new ratio, an equivalent ratio. What about if there are 10 adults? Can you guys figure that one out? Can you pause the video and give it a try? I want 10 adults. How can I convert 1 over 20 into 10 over something? Let's times it by 10. And I think we could have 200 students come to the dance. And if we try the last one, let's erase this so we can see, there's 400 students now. 400 students. How many adults do we need? Well, we know we start with 1 to 20. That always worked. And these were our students. These were our adults. Now we have 400 students there. How many adults do we need? Now we could totally guess and check. How do I turn a 20 into a 400? I could try it by times it by 3, times it by 4, times it by 5, times it by 10, times it by 15. But in this case, because I actually know the answer, maybe it might be easier to divide. What is 400 divided by 20? It turns out it's also 20. Okay. The fact that one thing divides by 20 means there's a relationship by a factor of 20 here. So if I want to turn 1 into the number I need, I can times it by 20. Now notice I put some arrows in here. I like arrows. Arrows tell me to do something, and the way that they point actually tells me what operation they're doing. Whenever my arrows point the same direction, I do the same operation. Notice these ones. They both pointed towards the right, and I times both things by 5. They both pointed to the right, I times both things by 10. But the last one, this pointed to the left and I divided. This one pointed to the right and I did the opposite. I multiplied. If your arrows point opposite directions, do opposite operations. Just a little trick there for you. Okay, let's continue talking about this equivalent idea. All of those ratios were equivalent. 1 over 20, 2 over 40, 5 over 100, 20 over 400. They're just different versions of the same ratio. Okay. And just different versions. They mean the exact same thing. 1 adult for every 20 students. If I have 2 adults, I can have 40 students. If I have 5 adults, I can have 100 students. But it's still the same ratio, 1 to 20. We call these equivalent ratios, and sometimes they're handy because they help us solve problems. I want to change my recipe. Okay, the recipe says 1 egg for every 3 cups of flour. But I need to make a really big recipe, and now I've got 20 eggs. How many cups of flour do I need? Or I'm mixing the oil, and it says 1 to 12. But I got to mix a whole bunch of it. What ratio do I need? How many parts do I need? So how do we find equivalent ratios? Well, the easiest thing to do is start by making it a fraction. If you're given a ratio, turn it into a fraction. Then pick some factor, some number, to multiply by or divide by. And we said we could do either one. So for instance, if I double this, I'll get 6 over 8. That's an equivalent ratio, a different version of 3 to 4. I don't have to choose times 2. I could pick another number if I wanted to. I could times it by 10. That's a nice number to multiply by. That's 30 over 40. Any factor you want, any number you want, just make sure you multiply the top and the bottom by it. Okay, try the next one yourselves. 24 to 18. See what you can come up with. Pause the video, give it a try. 24 over 18. Maybe I want to double that. That's the same as 48, if I times it by 2, over 36, if I times it by 2. Maybe you wrote down, I don't know, a different version, times it by 10 again. Those are the nice numbers usually that people pick. You don't have to. Maybe, just for fun, you decide I want to make a smaller but equivalent ratio. Maybe I divide it by 6. That gives me 4. If I divide top by 6, do the bottom by 6, and I'll get 3. That's an equal but different ratio, an equivalent ratio. Okay. Let's try some other things here with equivalent ratios. I want to know if these things are equivalent or not. How do I check? Well, let's turn them into fractions and ask ourselves, is there some factor that changes one equation into the other equation, or one fraction to the other fraction? So I can use some mental math here. 6 times what makes 18? Oh, that's times 3. If I times 9 by 3, do I get 12? No, I get 27. So these are not equivalent. Now, if your mental math doesn't work that way, the other thing we could do is let's try the dividing trick. So I'm going to erase these arrows here. What's 18 divided by 6? Oh, that's 3. What's 12 divided by 9? That's not 3. 12 divided by 9 is a decimal, right? 1.33, so on and so on. The fact that these are not the same numbers means they're not equivalent. Let's try the next one. Pause the video, give it a try. 2 over 5 and 15 over 35. Okay, let's see. Can I think of a number that makes them the same? I could try by multiplying. I could try by dividing. I can't think in my head. 2 times what makes 15? So I'm going to divide. 15 divided by 2 is 7.5. 35 divided by 5 is 7. Well, those aren't the same. Not equivalent. It's pretty quick to figure out things are equivalent or not. Now, the real reason we like this equivalent ratio idea is so we can solve problems. Okay. To find missing values. How does that work? Well, it's basically doing what we've been doing all along. So I've got a missing number right here. I want to know what it is if I know that this ratio is equal to this ratio. So what am I going to do? Write it as a fraction. Okay, the 4 goes on the bottom because it's second. 36 and 48. And then I ask myself, okay, how do I turn a 4 into a 48? Now, mental math, I can multiply or I can divide. 48 divided by 4 makes 12. If I need to turn a 36 into this missing number here, what do I have to do? Look at my arrows, they're pointing in the same direction. Let's divide by 12. And 36 divided by 12 makes 3. There's my missing value. And I did it by using equivalent ratios. We'll try the next one together here. 5 over 30 equals 45 over something. I need to turn a 5 into a 45. How do I do that? Well, that's what I can do mentally. 5 times 9 makes 45. So 30 times 9, arrows point the same direction, do the same thing, makes 270. If you don't like the multiplying way, use the dividing way. Just work backwards. Let's try the third one here. You guys can pause it. See if you can figure this one out yourselves. Something over 16 equals 9 over 24. Ooh, messy there. I can't really turn a 16 into a 24. So let's try my dividing trick. 24 divided by 16 is 1.5. I gotta turn a 9 into something divided by 1.5. Gives me 6. Need my calculator for that one, right? These are decimals. That's going to happen sometimes. Not a big deal. And notice my arrows point the same way, so I did the same operation. Just to go back for B for a second here. If you tried the dividing trick, in this one, okay, what was the missing number was there? 45 divided by 5 is 9, but I need to turn 30 into this number. So notice that my arrows are pointing opposite ways, so I'm going to do my opposite operation, but I still get 270. In case you tried the dividing one there and you're like, it didn't work for me, what happened? Okay, put the arrows on them so you know which operation you're doing. Okay, a couple of word problems. Nothing big, just can we interpret what's going on in the situation? Show you some little tricks here and how we can solve things that might be helpful in the real world. And the dimensions of a rectangle are in the ratio 5 to 3. The longer side is 18 centimeters. What is the length of the shorter side? So they're telling us we've got a rectangle. I've got 18 here. I don't know what that is, but I know a ratio. 5 to 3. Now here's one of the little tricks I was talking about. Put some letters in here to remind yourself which one's which. Which of these two is the long one? Which of these two is the short one? Well, 5 is longer and 3 is shorter. So if that's a known ratio, what else do I know? I know the long side is 18 centimeters. See, that's my long side. And I don't know the short side. Well, this looks like the previous questions, just developed from words. How do I solve this? I've got to turn a 5 into an 18. And I can't think off the top of my head how that works. I'm going to do my dividing trick. 18 divided by 5, that's 3.6. I need to turn a 3 back the other way, opposite direction, so that's times by 3.6. And I end up with 10.8. Now because this is a word problem, we should use a word answer. So we're going to say the short side is 10.8 centimeters. So we're done. Okay, let's try the next one yourself. Pause the video, see if you can figure it out. The recipe for homemade ice cream requires 5 cups of milk for 4 eggs. That's a ratio. I can see that right there. 5 milk for 4 eggs. According to the recipe, how many cups of milk should be used with 20 eggs? Well, where's my 20 going to go? Well, eggs are on the bottom. Milk's on the top. It told me there's 20 eggs. This is what I'm missing. How do I turn a 4 into a 20? Well, that's what I can do with a multiplying. Times it by 5. Okay, which means I got to turn this one by 5. That's 25. Okay, word problem, word answer. We should use 25 cups of milk. Okay. If I stamp the fractions and labeling them, you know which things go together. All you have to do is use your dividing or multiplying. I'm not picky which one you use. They work the same way. They're just different versions. Okay, last one. Henry went on a fishing trip. He hooked a walleye for every 2 bass he caught. What was his total catch if he caught 16 bass? So this one gives us the ratio, but in a tricky way. A walleye for every 2 bass. So 1 walleye for 2 bass. What was his total catch if he caught 16 bass? So the other part that I know is there's 16 bass. I don't know how many walleye he caught. But this one I can figure out pretty quickly. Times my 2 by 8 times my 1 by 8. Point in the same direction, same number. He caught 8 walleye. But there's an extra trick in this question. The question didn't ask us how many walleye he caught. It said what was his total catch. So I got to take my 8 walleye and my 16 bass and add them together to figure out his fish. He caught 24 fish altogether. Okay, so do be careful. We actually answer the question when we're done. Okay, on the website, you also have today's homework sheet if you weren't here. We're going to hand that one in as usual. Give it a try. If you're stuck on things, come bring it in tomorrow. I can give you some help if you're stuck. But that's our first lesson in this course on ratios.